structural assessments are still being used. Now, why is this really important? Buildings that are built with no seismic building codes will result in a catastrophic building failure. Therefore, with BIM as a collaborative digital tool and structural analysis for buildings to withstand loadings will result in an improved seismic performance assessment. This matters because it prioritizes the public safety and stakeholders can gather and collaborate on BIM software to build durable buildings. My research objectives are as follows, and the tools that I will be using are literature review, questionnaire and 3D modeling, such as Autodesk Revit and Robot Structural Analysis Professional. These are the current results obtained as my research is still ongoing. The respondents group are mainly structural engineers, modelers, and civil engineers. An analytical model will be completed from Revit to be analyzed for seismic in robot structural analysis. My research will benefit to others by firstly, it will assist structural engineers to construct a safe and durable building. BIM can be utilized into construction projects for seismic design, and last but not least, BIM modelers can collaborate with various stakeholders and coordinate design and data exchange to reduce design errors and revision. In summary, although my research is yet to be completed, it can be seen that the integration of BIM and structural analysis will greatly improve the seismic performance assessment of buildings. Before I end, as future engineers, we must not only build structures, we must build resilience. Let's bridge the gap between design and safety and model a future that stands.
Ladies and gentlemen, the event will begin shortly. We kindly invite everyone to take their seats as we prepare to start the opening ceremony. Thank you for your cooperation. Dean of the Faculty Engineering, University Malaysia Sabah, accompanied by Professor Engineer Dr. Willie Liu Yun Sian, Deputy Dean of Research and Innovation, and Engineer Dr. Nelly. Please be seated. A very good morning to Associate Professor Engineer Dr. Abu Zarim bin Yasir, Dean of the Faculty of Engineering, Professor Engineer Dr. Willie Liu Yun Sian, Deputy Dean of Research and Innovation, Engineer Dr. Nelly, representing the head of the Civil Engineering Program, Tuan Haji Zawawiti Yunin, head of U-Science, industry partners, judges, lecturers, students, and also the students from College Vocational Likas. Welcome to the Civil Engineering Exhibition 2025, proudly organized by the Civil Engineering Program, Faculty of Engineering, University Malaysia Sabah. To begin the ceremony, please rise for the national anthem Negaraku, followed by the state anthem Sabah Tanah Airku. Thank you. Please be seated. We will now proceed with a dua recitation. We invite Muhammad Zaim bin Musin to lead the prayer.
Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala asyrafil mursalin wa ala alihi wa ashabi ajma'in. Ya Allah, Ya Rahman, Ya Rahim, hanya padamu sahaja kami panjangkan kesyukuran atas segala rahmat dan berkat-Mu. Bukakanlah hati-hati kami, lapangkanlah dada kami, supaya kami dapat mengisi ilmu dan pengetahuan yang berguna untuk agama, bangsa dan negara. Kami mohon kepadamu agar Engkau berkatilah majlis ini dengan limpah rahmat-Mu. Semoga segala usaha kami dalam menjayakan majlis ini mendapat keredaan dan hidayah-Mu. Sesungguhnya pada hari ini kami berkumpul kerana-Mu, Ya Allah. Kami berkumpul untuk menimba ilmu, bertukar pendapat, menyumbang buah pikiran, menghubungkan silaturahim dan memberi sokongan ke arah meningkatkan lagi prestasi kami. Kami mohon kekuatan dan hadrat-Mu, Ya Allah, supaya kami yang hadir pada hari ini agar kami dapat melaksanakan segala kebajikan. Dan kami mohon perlindungan dengan Engkau daripada melakukan keburukan. Gunakanlah kepada kami kekayaan ilmu pengetahuan dan hiasilah diri kami dengan sifat lemah lembut. Gunakanlah kepada kami kesihatan badan, kecerdasan minda, ketenangan jiwa dan kekuatan semangat. Kami memohon kepada Engkau, Ya Allah, bantulah kami dalam menghadapi segala cabaran. Ringankanlah beban kami, sesungguhnya Engkau yang maha berkuasa. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar wa sallallahu ala Muhammad wa ala alihi wa sahbihi wasallam walhamdulillahi rabbil alamin.
Thank you. To start our event today, I would like to invite Engineer Dr. Nelly, representing the head of the Civil Engineering Program, to deliver her welcoming speech. Please welcome.
Thank you to the MC for today. Salam sejahtera and a very good morning. Yang berbahagia, Associate Professor IR Dr. Abu Zahrim bin Yasir, the Dean of the Faculty of Engineering, University Malaysia Sabah. Yang berbahagia Tuan Haji Zawawi Tiunin, Director of Youth Science and Chief Librarian of UMS. Yang berusaha Professor IR Dr. Willy Liu Yun Sien, Deputy Dean of Research and Innovation from the Faculty of Engineering, distinguished representative from industry, fellow lecturers, teaching staff and students from College Vocational Likas, dear students, ladies and gentlemen. First of all, I just want to share that I'm speaking today on behalf of the head of the Civil Engineering Program, Associate Professor IR Dr. Habib Musa Muhammad. He couldn't be with us today due to other commitments, but I'm truly honored to represent him on this meaningful occasion. It is my pleasure and honor to welcome all of you to the Civil Engineering Exhibition 2025 held here at the Youth Science UMS Library. Today's event, with the theme Unfolding Civil Engineering Ideas, is a celebration of innovation, creativity, and the culmination of the hard work of our students from the Civil Engineering Program. Let me begin by expressing our heartfelt appreciation to the Dean of the Faculty of Engineering, Associate Professor IR Dr. Abu Zahrim bin Yasir, for graciously accepting our invitation and for officiating our event this morning. Your presence, Doctor, reflects the strong support and encouragement for our students and their work. I would also like to extend our sincere gratitude to Tuan Haji Zawawi Tiunin, Director of Youth Science and Chief Librarian of UMS, and all his staff for enabling this collaboration through the Youth Science platform. And to the Deputy Dean of Research and Innovation, Professor IR Dr. Willy Liu Yun Sien, thank you for your encouragement and ongoing support toward research development within our faculty. Ladies and gentlemen, today we proudly present CVEX 2025, an academic exhibition that showcases the civil engineering research projects carried out by our students. And this year, we have 51 students participating in two core activities, the video pitching competition and the poster competition. And these projects span across 6 major clusters in civil engineering, which are geotechnical and engineering geology, structural engineering and materials, water resources and environmental engineering, project and construction management, structural design and materials innovation, and traffic and highway engineering. Now, each of these clusters contributes meaningfully towards the sustainable development goals. And the work displayed today is not just academic exercise, but part of a broader mission for a better and more sustainable future. And the true purpose of CVEX is not only to celebrate our own achievements, but to allow the industry to evaluate us. We do not wish to measure ourselves against internal benchmarks, or in Malay we call syok sendiri. Instead, we open the floor to our external partners, the government agencies and industries, to provide their perspective and to help us gauge whether we are truly producing graduates and research that meet the world standards. In this regard, I would like to extend my deepest appreciation to our esteemed panel of judges, especially from the government sector, such as JKR, and our industry collaborators. And some of you here are my former colleagues, including Dato' Amarjit. when I was in the industry. And I'm delighted to reconnect with all of you in this academic setting. And we're also very pleased to welcome 27 students and teaching staff from College Vocational IKAS. We hope that this will be a meaningful exposure for your students. And to all participating students, I wish you the very best in today's competition, and may this platform inspire confidence and deepen your passion for engineering and mark the beginning of your professional journey. And I would also like to thank my wonderful team, Dr. Jordan, Dr. Nurul, Dr. Eugene, for your dedication and hard work in making this event a success. My sincere appreciation also goes to the Civil Engineering Club. Thank you for stepping up to help organize this event even during the busy examination week. Your commitment is truly commendable. And finally, I hope everyone will enjoy today's program. May it be a platform not only to showcase ideas, but also to build connection, foster collaboration, and inspire innovation. Thank you once again, and I wish you all a fruitful and engaging experience at CVEX 2025. Thank you.
Thank you, Dr. Nelly. Next, I would like to invite Associate Professor Engineer Dr. Abu Zarim bin Yasir, Dean of the Faculty of Engineering, to deliver his remarks and to officially open Civil Engineering Exhibition 2025.
Thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera and a very good morning. Yang Berusaha Tuan Haji Zawawi Tunin, Chief Librarian of UMS, as well as the Director of Youth Science. Yeah. Orang yang sangat mengeberat tentang youth science. Yang Berusaha Profesor IR Dr. Willy Du Yusin, Deputy Dean of Research and Innovation, Faculty of Engineering. Yang Berusaha IR Dr. Nelly Majain, Deputy Head of Civil Engineering Program. Distinguished representative from industry, fellow lecturers, teaching staff from College Vocational IKAS, dear students, ladies and gentlemen. It is my pleasure to once again welcome all of you to the Civil Engineering Exhibition 2025. This exhibition marks a significant milestone for our students as they showcase their research projects, the result of years of learning, exploration, and hands-on experience. These platforms not only allow students to highlight their technical skill, technical knowledge, but also to develop important communication and presentation skills, qualities that are essential in the professional world. We would like to extend our sincere thanks to Youth Science, especially Tuan Haji Zawawi, for graciously providing the platform to host this event and for sponsoring the awards. Your continued support plays a vital role in promoting academic excellence and nurturing innovation among our students. I would like also to extend our heartfelt appreciation to all our industrial collaborators and government agencies who are here today, and especially those who have kindly contributed their time to serve as panel evaluators. Your insights and feedback are invaluable in helping our students bridge the gap between academic knowledge and industry expectation. So we have a big applause to our panel. Thank you so much. We are also truly grateful to our generous sponsors from industry, AUA Konsat Sdn Bhd Kota Kinabalu, Winabumi Sdn Bhd Kota Kinabalu, and Era Maju Synergy Sdn Bhd Kota Kinabalu. Your support has been instrumental in making this event a success and enriching the learning experience of our students. To all the students participating, congratulations. You have taken a courageous step by presenting your work for public evaluation, a vital part of both learning and professional development. Be proud of your efforts regardless of the outcome. I would also like to extend my congratulations to all the student supervisors for their dedication and commitment in guiding and supporting our students throughout their projects. Lastly, I would like to sincerely thank the organizing team, our dedicated lecturers from Civil Engineering Program, and the enthusiastic members of the Civil Engineering Club for their commitment and effort in making this event possible. Let us continue to uphold a spirit of innovation and excellence in engineering education. Thank you for being part of this significant occasion, and may this event continue to be held in the future. With that, I hereby officiate the Civil Engineering Exhibition 2035. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor. With that, we officially open Civil Engineering Exhibition 2025. We now proceed to the special project presentations under the STEM Speaker Series. This segment features innovative research projects by our final year civil engineering students. Now, let's welcome our first presenter, Mevalina Cera Binti Ronnie. She will be representing her research title, Performance of Zirconium-Based Metal Organic Frameworks Ligand with Amine as Absorbent in Removing Humic Acid from Stabilized Landfill Leachate. Please welcome. Hello.
Good morning, everyone. My name is Mevalina Cera Binti Ronnie. My supervisor is TS Dr. Siti Nur Farhana Binti Zakaria, and today I will be presenting my research titled Investigating Performance of Zirconium-Based Metal Organic Framework Ligand with Amine Carboxylic Acid, UiO66 NH2 as adsorbent in removing humic acid inside landfill leachate. Sounds complicated, right? But I'll break it down in a way that is easier for you to understand. Okay, so what is the current situation? My research study focused on treating this dark black wastewater known as landfill leachate. And inside this landfill leachate, there is a stubborn pollutant called humic acid. Humic acid is dangerous to the environment, harmful to human health and our water bodies. So, what is the limitation? Various treatment has been being used on site. However, it is not effective to remove HA effectively. So, I have proposed powerful adsorbent called UiO66 NH2 a metal organic framework that has potential to remove HA effectively. However, there are lack of research on using this adsorbent to remove HA in actual landfill leachate. They are only using synthetic HA to remove it. So, my research study focused on studying the potential of UIO-CEC KNH2 as adsorbent in removing HA in landfill leachate by varying dosage and pH and determine its effectiveness on biodegradability ratio. So, let's move on to the methodology. My research study is at Kayu Madang landfill site. I will do my sampling here, where I am doing monitoring for twice a month in 3 months and characterize the sample at the environmental lab in Faculty of Engineering UMS. Then the study was first started by synthesizing the adsorbent at the environmental lab. And first of all, we will mix two solutions, two chemicals named zirconium tetrachloride and 2-amino-terephthalic acid, and then heat it in the oven for 24 hours, centrifuge for 5 minutes, and then we dried it until it became this final product, which is this one. Okay. Then I will do the effects of dosage by varying dosage and then shake it in the shaker for 30 minutes and then measure the HA value using UV spectrophotometer. Then for effects of pH, I will use the optimum dosage found in the effects of dosage before and adjusted the pH to find and repeat the same process. Then I will determine the BOD5 over COD ratio to determine its biodegradability after treatment using the optimum condition found in the adsorption process before. So moving on to our result and discussion. So based on 3 months of characterization, I am comparing the standards with the Malaysian Environmental Quality Act to see the discharge limit. And as we can see, COD, BOD5, and color all exceed the standard discharge limit required by authority. And although HA and biodegradability ratio is not in the standard, however, other pollutants already proved that this pollutant is highly polluted. Now for this table, this graph shows the effects of dosage on HA removal, and we can see that that increasing the dosage will also increase the HA removal until it becomes constant at 0.17 gram, which this means that the mechanism that happens is hydrogen bonding between NH2 of UIO-CEC KNH2 and also COOH and OH of humic acid. Then for effects of pH, we have found that the highest removal is at pH 5 using the optimum dosage before, which is 0.17 gram. And this is might due to electrostatic attraction between NH3 plus between UIO-CEC KNH2 and also OH minus of HA. Lastly, this table shows the biodegradability ratio before and after treatment. And as we can see, the raw for BOD5 over COD is 0.03 and it has enhanced to 0.15 after the treatment. And so this is the raw sample before and using the optimum condition of dosage 0.17 and pH 5. This one. This is the sample after treatment. So this is the conclusion. The conclusion is we have found the optimum condition is to be at 0.17 gram at pH 5, and it is mainly due to hydrogen bonding and electrostatic attraction between UIO-CEC KNH2 or adsorbent and humic acid. The biodegradability also enhanced from 0.03 to 0.15, which means biological treatment will be efficient after this. That marks the financial support is provided by Ministry of Higher Education Malaysia under the Fundamental Research Grant Scheme. That marks the end of my presentation. Thank you. Any question? Any question? Yeah. What's in it?
Thank you, Mevalina, for the very interesting presentation. Just a simple question because actually I also did some work on this lichen. Yeah, okay. Just want to know because I know that's a new material that congratulations, you managed to come out with a new material, new absorbent for this. Just want to ask you, what is the mechanism for this? Humic acid removal. What is the mechanism? Yeah, can you please explain?
Okay, thank you for the question, Dean of Faculty. So for dosage, we have found that the mechanism that happened is between the hydrogen bonding between NH2 of the UiO66 NH2 and then the COOH and OH group of humic acid. While for pH, effects of pH, it is due to electrostatic attraction between the negatively charged of humic acid and the positively charged of UiOCC NH2, which is NH3 plus and OH minus. They will have attraction. Thank you. That's my question. That's my answer. Thank you.
Thank you, Mevalina, for the insightful presentation. Next, let's welcome our second presenter, Nuramirah Binti Muhammad Zaini. She will be presenting her research title, Synergistic Effects of Crystalline Admixture and Palm Oil Fuel Ash on Self-Healing Concrete Performance. Please welcome.
Assalamualaikum and a very good morning to everyone present here today. I am Nuramirah Binti Muhammad Zaini, and my research title is Synergistic Effects of Crystalline Admixtures and Palm Oil Fuel Ash on Self-Healing Concrete Performance. Today, I'll be sharing about something a little magical but also very real. It's about a concrete that can heal itself without anyone fixing it. So, without further ado, let's start with something that we all know, which is concrete. Concrete is the gray material that we walk on, drive on, and build the cities with. It's cheap, strong, and everywhere. However, concrete, just like people, it's not perfect. Why? Because concrete can crack over time due to carrying too much weight, or the weather too cold or too hot, or even it just shrinks as it gets older. So when it cracks, these cracks allows harmful agents like water, chlorides, and salts to get in and causing corrosion, durability issues, and other things. So this repairing make them very time consuming, expensive, and extra labor. So now imagine, what if concrete could fix itself without anyone fixing it? we can save so much time and cost on repairs. So, as you can see from the pictures, here you can see the cracked surface slowly, almost magically, start to heal itself. Meaning, this concrete doesn't just sit and break over time. It also reacts by repairing itself. So that's the whole concept of self-healing concrete, where it heals on its own. And it is built to heal and designed to last. However, so I did a research on self-healing concrete, especially with crystalline admixtures. So this is the crystalline admixtures. It is to form a crystal when a crack happens. So this is how the crystalline admixtures react with moisture to form a crack, like a tiny needle or blocks to fill the cracks and block the water from going in further. However, this material have limitation where it can only heal small cracks, and it takes time and also need moisture, constant moisture to effectively works. So this is where something local is introduced, which is palm oil fuel ash, or known as POFA. This is a burning waste from palm oil factories, which can help to strengthen the concrete matrix and reduce the porosity and permeability. And then, my research is mainly focused on what happened when we combine CA and POFA in self-healing concrete, and can the combination effectively overcome each other limitations in self-healing concrete performance. So what I did was I prepared the mixes, 4 mixes in total, which is normal concrete with no additives, and then CA mix with only CA 1%, and then POFA mix with 10%, and combination of both. And then this is the visualizations of how I induce the crack using 70 to 80% of the ultimate strength to induce the crack and reload it back to gain the strength recovery. It's also the same for water absorptions. And then what did I found during these studies is that the crack closure after 14 days of healing period achieved over 90%, meanwhile CA and the POFA mix only achieve 1%. So if you can see from the picture right here, this is the day 0 where I initially crack it. There's a crack right here, and after 14 days, the crack is already sealed. And you can see there's a mineral deposit that I mentioned just now, which is a crystalline to fill the pores and block the water. Meanwhile, for the POFA mix, the crack width remains mostly unchanged during the 14 days. And then the CA POFA mix also show no visible healing at all. And then for the strength recovery, for the CA mix, it's heal over 100%, meaning it gains strength back higher than the initial strength. And then as well as for the CA mix in softivity analysis. And CA POFA mix still perform the worst among all mixes. So the results that I get may be because of the properties of my material, which is the crystalline admixtures that absorb water, as well as the POFA, which is also absorb water. So they basically compete for water for hydrations. So they may not effectively crack sealing. So for recommendations, I recommend to extend the healing to 28 days and 56 days to further evaluate whether the combination can effectively do crack sealing, and then investigate varied CA and POFA dosage, and also adopt a controlled crack induction for further study. So that is all from me. Thank you. Do you have any questions for me? Yes. So hello. So for normal that we always do in the lab, we always do 28 days for curing. But for mine, I choose 14 days of curing to evaluate its early edge performance, as well for its curing, as well as for healing period. It's also 14 days to assess its early age crack healing performance.
Once again, thank you, Amira, for the insightful presentation. Lastly, let's welcome our third presenter, Edward Clinton Petrus. He will be presenting his research title, Hydrobitumen C Innovative Asphalt. Please welcome.
So, good day, everyone. I am Edward Clinton Petrus, and today I will introduce to you a new material, which is hydrobitumen C for construction of innovative asphalt. So, as we know, road are the main infrastructure that we use every day in our daily life to commute from one place to another. But as of now, our road is constructed by using the conventional asphalt pavement, which is the material are aggregates and dust, and then mixed with bitumen to form the aggregates coated by bitumen, and then compacted by using gyratory compactor to produce conventional asphalt. But then, as we can see, especially in Sabah, we can see that the road deterioration is very many, and we can observe it in many places. And the deterioration is as tripping on wheel tracks, reveling, and potholes. So this is where my innovative solution comes in, which is by using hydrobitumen C as the asphalt binder. So the hydrobitumen C is a bitumen that contains 5% of hydrogenated cap-lump natural rubber. And the benefits of using this binder is, the first one, it decreases the moisture susceptibility of asphalt. The second one is reducing the surface crack of asphalt. And then the third one is, it slightly increases the tensile strength of asphalt. So this is the example of the hydrobitumen C innovative asphalt. You can see here, this is the control sample which has been tested by indirect tensile strength test, and then this one is the sample that contain the hydrobitumen C. So, moving on to my experimental methodology. First, I conduct the materials preparation, and second one, I mix the bitumen plus the aggregates and also the hydrobitumen C. I mentioned bitumen and hydrobitumen C is because I conduct 5 types of sample. The first one is the control sample, which is using only the conventional bitumen. The second one is hydrobitumen C that contains 2.5% of HClNr. The third one is the sample that using hydrobitumen C that contains 5% HClNr. The fourth one is 7.5% HClNr. And the last sample by using 10% of HClNr. So, I conduct 3 laboratory tests in order to test the performance of all these asphalt sample. I conducted tensile strength ratio to assess the percentages of retained strength of asphalt after being conditioned, soaked fully in water at 60 degrees Celsius for 24 hours. The second one is indirect tensile strength test. It is to measure the maximum tensile stress of the asphalt mixture can withstand before it fell. The third one is I conduct cracking pattern analysis by using MATLAB software. So moving on to the laboratory test results. For the tensile strength ratio, I get that the 5% HClNr content in hydrobitumen C is the ideal content, which is it retained 87.09% of the asphalt strength. Whereas for the control sample, it only retained 83.73% of the asphalt strength. And the JK requirement is only 80% of retained strength. Next one is the indirect tensile strength. We can see that only the 5% HClNR content that can get close to the control sample tensile strength. And then for the last test that I conducted, I do the digital image analysis by using MATLAB software, which I adapted from Huang et al. 2022. And I adopt his method of coding to assess the surface cracking area. And this is the cracking area that I get, which is the 5% HClNR content only have 19.23% of crack area versus the non-crack area. And for the JK requirement, it only require below 35% of surface crack area. So, my summary of findings, all the three tests point to the 5% of HClNR as the ideal content to be used to enhance the asphalt pavement moisture susceptibility, tensile strength, and also the cracking patterns to be lower than the control sample. As a conclusion, hydrobitumen C improved the moisture resistant, tensile strength, and also the crack resistant. And it is also suitable for Malaysia hot weather, heavy rain, and high traffic roads. And it also helped reduce common road problems like stripping, raveling, and cracking. And the last one, it can extend pavement life and reduce maintenance for Malaysia roads. So that's all from me. Thank you. If there are any questions, I'm open. Thank you. Great question, great question. I like that question. So, first of all, as we are using the modified bitumen, obviously the initial cost will also increase, right? Okay, so we cannot just look at the initial cost. We must also look at the long-term cost. So if we conduct LCCA or life cost cycle analysis, we can see that the maintenance cost will be lower if we use this hydrobitumen C innovative asphalt. So I am very confident that this new innovation can help our road, especially in Sabah, to reduce the potholes that we can see at many places in Sabah. So yeah, I hope that answers your question.
Thank you, Edward, for the insightful presentation. And that concludes our STEM speaker series. Let's give a big round of applause to all our presenters. And now, moving on to the next section, we begin our award ceremony by recognizing the contributions of our industrial panels and judges. To present the certificates and plaques, we respectfully invite Associate Professor Engineer Dr. Abu Zarim bin Yasir, Dean of the Faculty of Engineering, accompanied by Engineer Dr. Nelly, representing the head of the Civil Engineering Program, to come on stage. Firstly, I would like to invite Dr. Engineer Technologies Builder Project Manager Dr. Armajit Singh. Next, I would like to invite Engineer Al-Sharif Ramzi. Next, I would like to invite Engineer Wong Chun Jack. Next, I would like to invite Engineer Roland Ng Chiu Ming. Next, I would like to invite Engineer Zainaza Ahmad Banjar. Next, I would like to invite Miss Adrienne Cheryl Tan. Next, I would like to invite Engineer Technologies Builder Dr. Nguyen Min Phui alias Tom. And lastly, I would like to invite Engineer Pat Royston. Thank you, Dean and Dr. Nelly. And once again, our sincere appreciation to all judges and partners. Next, we now recognize our special project presenters for their participation in today's STEM Speaker Series. To present the certificates, we respectfully invite Tuan Haji Zawawiti Yunin, Head of Youth Science, accompanied by Engineer Dr. Nelly, to the stage. First, I would like to invite Mevalina Cera Binti Ronnie. Next, Nuramirah binti Muhammad Zaini. And lastly, I would like to invite Edward Clinton Petrus. Thank you, Tuan Haji and Dr. Nelly. And congratulations again to all presenters. We now move on to the next segment. This year, the Civil Engineering Program organized two competitions, which are video pitching competition and poster competition. The awards will be presented by our esteemed industrial partners. And now I would like to invite our CIVEX coordinator, Dr. Jodine, to announce the result. But first, I would like to invite the representative from Wina Bumi Sendirian Berhad to present the first four awards. Please welcome.
Okay, thank you, Wina Bumi. They are one of our sponsors. So there are 10 winners for the video pitching competition. So Wina Bumi will present the first 4 awards. There are more than 50 video pitching submitted, but here are the 10 winners evaluated by panel of judges from industry and also academics. The first 4 winners are: number 1, Nuramirah Binti Muhammad Zaini. Congratulations to the first winner of video competition. This is evaluated through YouTube video. The second winner is congratulations, Hasmirul bin Razman. Congratulations. The third winner for video competition is Vianney Azlin James. Okay, congratulations to the winner. And the fourth winner is Mevalina Cera Binti Ronnie.
Thank you, representative from Wina Bumi Sendirian Berhad. Next, I would like to invite the representative from AUA Consult Sendirian Berhad to present the next 3 awards. Please welcome.
Thank you. The next 3 winners are as follow. Congratulations, Muhammad Tajuddin bin Ismail. Next, congratulations, Bernice Annette Hughes. Thank you. And next winner is Albert Aston Philippus.
Thank you again, representative from AUA Consult Sendirian Berhad. And lastly, we invite the representative from Era Maju Synergy Sendirian Berhad to present the last 3 awards. Please welcome.
Okay. The last three winners for video competitions. Congratulations, Edward Clinton Petrus. Next, congratulations, Masya Maya Aliandra binti Muhammad Azwani. And lastly, congratulations, Evia Nesa Polodius. Okay, so this is the video pitching competition where students are required to present a 3-minute summary of their research on YouTube evaluated by the industry panel. So today we also have the poster presentation. So what the major difference is that in poster presentation, not only you are required to present, but you also have to answer questions from the panel.
Thank you to the representative from Era Maju Synergy and congratulations once again to all winners. Next, we present the Best Poster Award given to the individual that demonstrated outstanding clarity, creativity, and visual design in their poster presentation. To present the certificate and cash prize, we respectfully invite Associate Professor Engineer Dr. Abu Zarim bin Yasir, Dean of the Faculty of Engineering, Tuan Haji Zawawiti Yunin, Head of Youth Science, accompanied by Engineer Dr. Nelly on stage.
Okay, so we have come to the final prize, the major prize, which is the poster presentation conducted today. First of all, thank you once again to the panel of judges from the industry. Not only that, they help us with the assessment, they also help us with the picking the winner. So there are a lot of good winners, but at last we have 3 top winners. Here are the winners. As mentioned by our MC, they also received cash prize. So thank you to the sponsor for this. And also the top 3 winners, after this you have to stand next to your posters. You'll be interviewed by the students from College Vocational Likas. Yeah, the 3 winners, you have to stand by your poster, and the student from College Vocational Likas will be interviewing you after this. Okay, so are you ready for the 3 winners? All right. So there is no number 1, number 2, number 3. They are all winners. So the first winner, congratulations, Evia Nesa Polodius. Poster number HT02. The title is Optimizing of Mixing Parameters for Hydrogenated Kaplam Natural Rubber on Modified Bitumen. Congratulations to the student. Is the supervisor here? May I ask, is the supervisor here? No. Thank you and congratulations to the first winner of Best Poster Award. Next winner is Adriana Amira binti Arsad. Poster code ID MS18, and the title is Investigating the Effect of Thermally Treated De-Oil Bleaching Earth and abaca fiber on the properties of ready-mix mortar. Congratulations again. And now, the third winner. Are you ready? The third winner is... Can you guess? Hasmirul bin Razman. Poster code MS10. The properties of pile-based slurry containing the oil bleaching earth and rubber crumb for an interlocking brick production. Congratulations to all three winners.
Thank you again to all VIPs. And congratulations once again to our Best Poster Award recipients. Ladies and gentlemen, that brings us to the conclusion of today's event. We hope you had an insightful and inspiring time filled with innovation, collaboration, and meaningful connections. As we end this memorable day, let us stand together in unity and pride for our university. To officially close today's event, we invite everyone to rise for the UMS anthem, UMS Bertekad Cemerlang.
UMS lambang puncak jaya, pancaran perjuangan semangat wajar, membentuk citra pelindung budaya, memandu bangsa memaju negara. Di sini dicatat segala pikiran, di sini dikaji segala wawasan, ilmu iman sumber pedoman, nanti curah kasih budiman. Bayu bertiup nafasmu sejati, bumi terhambat untukmu abadi, samudra biru wajahmu berseri, sudah menghina tenagamu murni. Kaulah harapan bangsa maju, kaulah jambatan usaha bersatu, berdiri megah bermutu, menuju arah kaki tuju. UMS lambang dan negara, warisan sejati Malaysia tercinta, bertekad cemerlang menjadi budaya, semoga unggul dan sejahtera.
Thank you. And now we invite all VIPs, guests, and participants for a group photo. Please stay at your remaining seat.